So let's first underline, we have it intersects at t equals k and t equals 2.46. So it's pretty obvious that 2.46 is right here. 416, I mean. But the k value is what we have to actually compute for, and we'll wait on that k value for part B. So it's saying how much water will be in tank A. So I'm going to look at this equation, and that's the rate. And for me to figure out how much water, we need to integrate it. So I want you to write out math number 9. And you're only writing this down just so that you have a way to study from. So we have the integral. It says we're starting at 0, and we're stopping at how many seconds? 4.5. Is it in seconds or minutes? Hours. And then a of t, dt. So let's go ahead and type this in on our calculator together. So we have math 9. We're going from 0 to 4.5. This is more of a freebie. And then we have our function here. So I'm going to go ahead and start with my own parentheses because 2t minus 5 has its component as one whole thing together. Plus 5, and then my second natural log is going to give me the e. 2 sine of x. Let's close it, dx. And it should give me some positive value because we know it's everything above the x-axis. And let's round this value to 3 decimal places. That's going to give us 66 point what? 532. 532. And again, it has to be in sentences. So I would steal the sentence stem from the original question. It says, tank A at time t equals 4.5 is going to accumulate that many liters of water. So let's write out tank A at time t equals 4.5 contains, or has, however you want, 66.532. And what was the units on this one? Liters of water. And then the way the AP graders are going to grade is the following. Having this right here, the integral with a of t, that's 1 point. And having the sentence with units and everything has to be another point. So over-explain yourself, repeat if you have to, because in the end, they want to make sure they see the time t, tank A, and so on. What's up?
How do we know that we need to integrate instead of just doing like math 8?
On this, math 8 will be the derivative. When you're finding the area under the curve, it is the integral. Okay? Let's go on to part B. Tate, let's read. So we're looking at difference between tank A and tank B. So here's the idea. So all eyes on the board real quick. So from 0 to k, I have more under the curve on the B of t, right? And then under the curve, we have less of A of t. So I need to take the rate of B of t minus the function. And we have to first find something though. Let's find what the k value is. So they gave us 20.5. Put that in y1. Let's all put in 20.5 in y1. Because I need to figure out where is it intersecting. And then put in the function of a of t into your y2. The nice thing is a 2.416, we don't need to calculate. That was already given to us. And I will be kind of clever on the window. When you get to the window, I know Zoom 6 is pretty friendly window, but here's what I would do. On your window, because my y1 is over 20, I want a number that's going to be way over 20, and I chose to put y max as 40. If you put 100, that's fine. Because you want to be able to see the window, the graph within it. When you're ready, go to graph. And I already had it graphed. And the nice thing is you could kind of compare and be like, okay, is this graph that I see on A of t? Yes, it is. So we're looking for this value right here. So we do second calc. What button is our intersect? 5. So I'm going to go over to my first intersection. And when I press 1, 2, 3, enter, it's going to give me some number. So let's put on here, we did y1 is equal to 20.5. And then we did y2 was A of t. And then we found that k value was some decimal point, but I'm going to store this number. It was 0.892. And let's store this as value of k. You don't have to store it. You can keep typing the decimal if you want, over and over and over. So we did kind of go over this trick a while ago. When you press X, it remembers the most recently calculated value. So it should give us the same number of 0.892, yes? And I'm going to store it. And store is right above the on button. And I'm going to store that into my k. So alpha k is going to be right here. So anytime I bring up the variable k, it's going to give me the whole value without rounding. And if you're having trouble, check with your neighbor, because I can't get to your calculator. So it's asking us to find the difference between them. So our difference in this case, it's going to be integral from 0 to k of 20.5 dt minus the integral from 0 to k of a of t dt, because they asked us to find the difference. And we knew 20.5 because they gave us, that was the rate. If that is the rate, to undo the rate, we have to integrate it. So let's type this in together. We have math 9. The k value is going to be saved as that silly decimal, 20.5 dt, and in our case it's dx, minus math 9 again, 0 to k, of that equation. And then we have alpha natural log is going to give me the e to sine of x. And then that's going to give us a difference between top minus the bottom. I got 10.599. So let's put 10.599. So let's look at our sentence stem. This one's going to be kind of long. I'm going to say the difference between the amount of water in tank A and the amount of water in tank B at time t equals k is blah. So I'm going to try to slow down. Okay, the difference between the amount of water in tank A and I'm going to say and tank B. Kind of abbreviating it, but everything is on there. At time t equals k. Now, will the AP graders take off for leaving variable k? No, as long as you specified it previously, they can always say that is credit. Okay? Is 10.599 liters. So our points are going to come from the following. Let's see. You'll get 1 point for the first integral, another point for the second integral, and your final answer in sentences, 1 point. So I'm going to do C at the very end. Let's go to D. And D has to do with the PVA. Okay, Kara's going to read D on this one. On the back. Oh, it's on the back.
During the time interval 2.7 hours to the rate at which water flows in the tank B is multiplied by WT equals 21 minus 32 divided by T squared liters per hour. Is the difference WT minus AMT increasing or decreasing at time equals 3.5? Show the work that it's doing.
So I told you guys prior to this, if you get stuck on C, does that mean you're guaranteed to be stuck on D? This will be a good example, okay? So if we're looking at something as increasing or decreasing, I want you to underline something. When something is increasing or decreasing, that means our slope is going to either be positive or negative, yes? So in this case, they gave us to us in an, what's it called, differences. So I'm gonna go ahead and say it is increasing if W prime of t minus A prime of t is increasing, it's going to be what? Positive? And then it'll be decreasing if Well, W prime of t minus A prime of t is what? Negative. I'm just kind of thinking out loud, okay? So then, let's go ahead and plug it in. We're looking at the prime. Prime is math what? Math 8. Let's all do math 8 together. So we have of x. So W of t, that's going to give us, I think I'm going to put this all in parentheses. 21 minus alpha y equals. There may be a calculator error on this one on my end because I make silly mistakes. To the power of 2. And then close it. That was just for W of t. For A of t, I'm going to go ahead and plug in. And we have the function on the back somewhere. I'm going to start with another parentheses and one more. The first parentheses is to wrap up the whole equation. Second one is for the 2t minus 5. Close it. Plus
Plus 5.
alpha natural log. We have, oh, I forgot the 5, right? Did someone catch that? 2 sine of x. And I may need to close it maybe twice. And the value was at 3.5. Let's see if I got lucky on this one. Maybe. Yep. So we know. Let's go ahead and put in W prime of 3.5 minus A prime of 3.5. We got negative 1.143. Is that positive or negative? So I'm going to say that is less than 0. So let's go ahead and take our sentence stem. I'm going to go from the difference between blah, blah, blah at t is equal to, or is decreasing. So let's put difference W of t minus A of t. Is it increasing or decreasing? It is decreasing at time 3.5 because the primes are what kind of number? Negative. Is negative. Okay, the points. Finding that we have a negative value is going to be 1 point. And again, the whole sentence with the time and the value is going to give you another point. All right, let's look at part C. Okay, Marissa, go ahead and read part C, please.
The area of the region bounded by the graphs of y equals a of t and y equals b of t for k is less than or equal to t is less than or equal to 2.416 is 14.470. How much water is in tank B at time t equals 2.416?
So let's look at the visual. It's saying how much water was between here to here and here to here. So we're really going to split it into two different integrals. So let's start by writing out the following. And also put on here k value. You don't have to repeat it, but just for your sake, let's put k is equal to 0.892. You do not have to, so you're not flipping back and forth. So they're asking us tank B. So integral from 0 to 2.416. But we need to break it down to two different integrals of b of t dt. So the first integral is going to be from 0 to k. And don't we already kind of know the value of that? Okay, so we have b of t dt. And then I need to go ahead and go from that k value to 2.416 of b of t dt. And we know this was already given to us. I need someone to calculate the following. 0 to k of 20.5 dt. Plug that in. Anybody? K is not a variable anymore. It is a number. I need two people to confirm the number on that one. It's something in the tens. $18? Very good. So we have 18.286. The only issue on this one is this guy right here. This guy is the issue. So I'm gonna kind of talk about what the issue could be. So eyes on the board. Oh, where's my paper? Oh, here it is. So I need to figure out what is the value of, from this value to this value. This is my goal. But do I have any equation for B of t? We do not have an equation, but what I can do is the following. I could take the area under the curve from A of t, and don't we already know what this value was by the given? They said that value was 14 point what? 14.47. So here's what I can do. I could take the area under A of t and subtract out 14.47, and that's gonna give me B of t. Do we all see that? Basically big minus small. So on your part C, let's write the expression. This one's gonna be plus the integral from k value to 2.416 of A of t, that's a big minus, dt, minus a small one was given to be as 14.47. Right here. The value from k to 2.46 is 14.47. Okay, someone type this in for me. I know the A of t is kind of long, but go ahead and endure through. And I need two people to confirm what this is gonna give us. This right here. It'll give you some positive number. That's all I can tell you at the moment. And 14.47 is the area, so that one you're not integrating. That's independent. And you should get something in the 30s. How many? 0.027. So then when I add 18.286 along with the 30.027, that's going to give us 48.314. So let's go ahead and take our sentence then. I'm going to start with that one. Okay. Tank B. At time t is equal to 2.416 contains 48.314 liters of water. Mm-hmm. Oh no.
So the 18 might not be right.
18 is correct because on my end it was correct. Okay, let's look at the point system. Knowing to get to A of t, this part right here is going to give you 1 point. Like literally this part right here. And then our final answer with it in a sentence is going to give you another point.